All right. I want to talk to you about adding and subtracting rational expressions. This is not quite the same as when we were multiplying and dividing. Multiplying and dividing, we factored everything out and then just canceled whatever we could cancel. Right now, we want to work a little differently. When you add or subtract fractions, remember, rational expressions is just another way of saying fractions that have variables in them. There's one key thing you have to remember. Every time we're adding and subtracting, we're looking for a common denominator. And so I'm just going to do a bunch of examples just to show you what I mean. Oh, I'll use pink. Okay, number one. I'm adding two fractions. They have a common denominator. They both have an x plus 3, so yay. Sidebar for a second. If I took 1/7 plus 3/7, think about how you would add those. We wouldn't add the 7s and get a 14. We would rewrite the denominator, the 7, and just add the numerators, the 1 and the 3. So 1/7 plus 3/7 is 4/7. Okay? So if we do that, then we have to look at the same exact concept here. I have the same denominator. So what I'm going to do is I'm going to rewrite the denominator. We don't change it. And then all I have to do is add, oh, I can leave that there, I think. Add the numerators. 5 plus 8 is 13. Done. Now, number 2. Same thing. I am subtracting two fractions, and they have a common denominator. The difference is the numerator is a little more complicated, but that's okay. Two things that we have to deal with. More complicated numerators and a subtraction. I jumped too far there. All right. X plus 2 is the denominator for both. That is my common denominator. So I'm just going to rewrite my common denominator. You have to be very careful when you are subtracting. Adding and subtracting, I'm looking for like terms. 3x minus 1x is 2x. So I'll put a 2x here. Now here's where it gets tricky. This minus sign, you have to be very careful because it does not just go to the x, it goes to the x and the 6. So you have to be very careful to distribute it. This is not -4 plus 6, positive 2. It's -4 minus a positive 6. -4 minus 6 is -10. Now, I need to be leery of my answer because my answer I see in the numerator, I can divide those both by a 2. I need to check and make sure that this is not a fraction that can still be reduced. So, let's take out the common factor of 2 from the numerator. 2 times the quantity, 1x minus 5 is my numerator, and then an x plus 2. Can I cancel the x's? No. Can I cancel this 2 with this 2? No. This 2 is chained to this x. Either I cancel with an entire x plus 2, or I don't touch. So I'm done. That's my answer. I would accept either one of those. But this one shows me that you checked, because sometimes there will be something you can cancel. All right, let's try this one. The difference here is I do not have a common denominator anymore. So I need to figure out what my common denominator is. If I had a situation where I had a 1/7 and a 3/2, well, I have to ask myself, what do 7 and 2 both go into? The answer would be 14. So I'd have to rewrite these as two fractions that are over 14. I can't add them until they have the same denominator. So I just need to rewrite this in a different form. Well, 7 times 2 gives me 14. So 1 times 2 gives me 2. 2 times 7 gives me 14. So 3 times 7 gives me 21. Now I have rewritten these two fractions. Could you reduce this? Yes. What would it give you? 1/7. I don't want to do that right now. I still need to add them first. I need them to have a common denominator so that I can add them and get 23/14. Same thing is true even if there's variables. All right, I need a common denominator. So I need to rewrite these two fractions so they have something in common. Well, what do 2 and 8 both go into? Well, 16 is an answer. It's not my best answer. My best answer is probably 8. That's the smallest number. So, let's see. This has an x squared. There's 2 of them. This has an x. There's only 1 of them. So, how do I make them the same? Well, let me back up just 1 second. To make this first fraction in 8, what does it need? It needs a 4. I need to multiply by 4. So I would multiply top and bottom, whoops, by 4. This one, 8 goes into 8, no problem. But I need to figure out my x's. X squared and x, well, x goes into x squared, so that would work if they both had an x squared. But this one has an x squared, I'm good. When I multiply by 4, I've got 8x squared. This one just has an 8 and an x, 1x. I need another x. So I'm going to multiply top and bottom. Let me move my equals over by x. Get my handy dandy purple, bluish purple, and move that over. All right, let's fix these. The first one has a denominator of 8x squared. Good. Has a numerator of 12. So I'm going to put a 12 here. Second one has a denominator of 8x squared. Good, I got that. It has a numerator of 5x. I now have 2 new fractions that are equivalent to what I started with, written in a different form, that have a common denominator. So I can add them together. I rewrite my denominator, and I add my numerators. Well, my numerators are not like terms. So the best I can do is write 5x, because I want them in the right order, plus 12. That's it. We don't do as many of these, but we need to practice those. But some of them are a little bit more complicated. I don't know if it's harder, but just different. All right. I have 2 fractions that are being subtracted. They need to have a common denominator. They look nothing alike. But what I am going to do is factor them. All right, x squared minus x minus 6. I'm going to go to 2 parentheses. X squared is x times x. How much time do I have? I can't see from here, but it's cutting it close. What 2 numbers multiply to give me 6, but subtract to give me -1, or even 1. That would be 3 and 2. So I'll put a 3 and a 2. To get a -1, it's a -3 and a +2. Okay, I rewrote that in factored form. This one, wait, there's a common factor of 5. So I'm going to rewrite it as 5 times quantity x plus 2. Now, I need these 2 fractions to have common denominators. So, hold on 1 second. I might have to stand up. Let me move this up here. Okay, this is where you ask yourself, what does this not have that this one does? Has an x plus 2, this one has an x plus 2, but it doesn't have a 5. So what I'm going to do is I am going to multiply both sides, top and bottom, by 5. Now this has a 5 and an x plus 2. This one has a 5 and an x plus 2. All right? Now this fraction, what does this not have that this one has? An x minus 3. So I'm going to multiply top by x minus 3 and bottom by x minus 3 so that it stays equivalent. All right, so what do we have here? I think I can sit now. All right, My new denominator is 5 times x minus 3 times x plus 2. And I'll just write this, even though it's not in the same order, that's not important. As long as I have all of them, I have an x minus 3 and I have an x plus 2. I need to now distribute or multiply out to get my new numerators. I have an x minus 1 times a 5. A 5 goes to both of them, and I get 5x minus 5. Over here, I have a 4 times an x minus 3. That's 4x minus 12. Scooch back. Okay. It gets kind of tiring writing these denominators over and over and over, but we'll get there. All right, again, have to be careful. It's a subtraction. So I have to make sure this minus sign goes to both of these. Let me put this down. 5x minus 4x is 1x. Negative 5 minus negative 12 is the same thing as negative 5 plus 12, which is positive 7. There is nothing to factor out of the numerator, and I can see that it won't cancel. There is no x plus 7. I'm done. Next one. Do it again. Look at the denominators, factor them. What two numbers multiply to give me 16, but subtract to give me 6? 8 and 2. So I'll try 8 and 2. I want a negative 6. It's a minus 8 and a plus 2. Second one. X squared is x times x. What two numbers multiply to give me 40, but subtract to give me 3? 8 and 5. Uh-oh. It's a negative 3, so it's a minus 8 and a plus 5. I see these are close, but they're not the same. So what I'm going to do, I'll use blue this time, and I'll move my 5 up here. Whoop, didn't want to work. Okay. What does this not have that this one does? An x plus 5. So I'm going to multiply top and bottom by x plus 5. What does this one not have that that one does? Yep, x plus 2. All right, so let's clean this up a little bit. I have an x plus 5. This is a fun denominator. An x minus 8. And an x plus 2. Hello. Oh, let's see, they're starting to come in. I got to work fast. All right, x plus 5 times 8. Distribute the 8 to both terms. And get
It's great. I'm going to get water.
x. Okay, I'm videotaping right now.
Sorry.
That's all right. 8x plus 40. The second fraction has the same x plus 5, x minus 8, and an x plus 2. What's my numerator? It's 9 times x plus 2. 9x plus 18. Like I said, I'm getting tired of writing this denominator, but you can take shortcuts if you need to, but not in your final answer. I need to see all of it. X plus 5 times x minus 8 times x plus 2. And what is my numerator? Add them, like terms. 8x plus 9x is 17x. 40 plus 18 is 58. Wait a minute. 17 times 4, I think it's 68, not 58. So I'm pretty sure I can't reduce this. I'm good. Okay, I just have to check. Yep, it's 68, so I'm good. If it was 58, we might have to factor that out. And if we did, we'd have to then see if anything canceled. But we're good? All right, good luck.